All right, what's up, guys? We're going through our angle review here today. So just some terms to go through first. A point is just a location in space. It has no size, no dimensions to it. A line is a collection of points that extend forever, okay, in both directions. We name it. First of all, we name a point by just a capital letter, so like point A here. If we wanted to do a line, we would do AB with a line on top of it to indicate that it's a line, not a line segment, okay? Or we could rearrange it and call it BA. If there was another point on the line, like point C, I could also call this line AC, CB, or ACB. So those are the things to keep in mind here. A plane is a flat surface. It extends without end. It has no thickness, all right, and it contains points and lines on it. So you kind of imagine like your floor is an example of a plane, all right, where it's a flat surface, there are lines on it, there are points on it, but it goes on forever and ever and ever. Now we name a plane with 3 letters that are not on the same line. So I could call this plane ABC, or I could use this letter P, which is not a point, right? Okay, so I could use a point, I could call this plane P as well. A segment is a measurable part of a line. It's all the points that are in between 2 known points. So this would be line segment AB. Okay, once again, we would name this with AB, and we don't put arrowheads on the top, or BA. Okay. If there was a C here, we could call this ACB, but it has to begin and end with A and B. A ray is a collection of points that start at one endpoint and move forever in one direction. Okay, favorite band, I know it. All right, so this would be ray AB with the line going over it. If I put the B first, I would have to flip the ray to indicate that it's going from A through B here. Okay, and same thing, if I put C here, I could call this ray AC as well, okay, or ACB, as long as the arrowhead is pointing in that direction. Okay, angle pairs. So some angle pairs we're going to talk about. You guys can pause it here and kind of fill in the notes if they're not there for you. Adjacent angles, all right, are 2 angles. They're on the same plane, okay? They share a common vertex, but no interior points, all right? So for example, angles 1 and 2 here are considered to be adjacent angles because they share a side. 3 and 4 would be adjacent, but this entire angle, let's call this ABC. Angle ABC and angle 3, for instance, would not be because one is inside the other. Vertical angles are opposite angles that are formed when the 2 lines intersect. So angles 1 and 2 are considered to be vertical. Okay, they are also equal. And 3 and 4 are considered to be vertical, and those are also equal. Okay, and I actually should be using 1 arc and 2 arc for these. So the 1 arc indicates that these 2 angles are equal. The 2 arcs indicate those 2 angles are equal, but since they have a different number of arcs, they indicate that they are not equal to each other. So we mark congruence with angles with drawing a little arc. And if I wanted to indicate the 2 sides here, for example, were equal, I would mark it with a slash. So sides get slashes, angles get arcs. Complementary angles are 2 angles that add to 90. All right, so if they're complements, it means they add to 90. So for example, it could be 2 angles that form a right angle, or it could just be 2 angles that are located not even connected to each other, but together make 90 degrees. And supplementary angles is the same thing, except they add to 180. So I always remember the C comes before S, just like 90 comes before 180. So complements are 90 degrees, supplements are 180. Like complements are right? Okay. So these angles form a straight line, so they're supplementary. And you might have an angle over here that's 137, and the other one apparently got cut off, which would be another one that adds to give you 180, so 43. And that would give you 180 degrees here. All right. Now I name an angle by using either one letter, if it's the only angle there. So for example, I could call this angle C. This could be angle C here because it's the only angle C. But if I put letters here, A, B, C, and D, I can't call angle 3 here angle B because there's more than one angle. So I'd have to call it, use the angle symbol, A, B, D, 3 letters where the vertex is in the middle, or angle D, B, A. Okay, vertex is in the middle. And you guys will learn this next year too in geometry, so it's just a little kind of primer for that. Corresponding angles. Okay, corresponding angles are formed when we have two parallel lines and they're cut by what's called a transversal. So a transversal is a line that intersects two or more parallel lines. All right, corresponding means they're in the same position. So for example, if we were to look at this intersection and we were to look at angle 1, okay, if I were to transfer this intersection down here, angle 1 would map onto angle 5. Okay, you guys see how that works? Angle 1 gets shifted down onto angle 5. So angle 1 and angle 5 are what's called corresponding angles. These angles, get rid of that stuff, are equal. So this angle, we broke it, is equal to that angle. They're corresponding. Okay? Likewise, angle 2 and angle 6 are corresponding. So these angles are congruent. I need two arcs here to indicate congruence. All right. Okay. The next one is called alternate interior angles. So alternate means they're on opposite sides of the transversal and they have to be on different parallel lines. Okay. These angles are also equal. Interior means they're inside the parallel lines. So if you look at angle 4, okay, it's going to be opposite side of the transversal. So it's got to go move from this side over to this side, okay? And it's got to switch parallel lines. So I got to be talking about angle 6. So I switch sides, switch parallel lines, and I'm down here. Now I like to call these the Z's knees, because these angles form a Z, right? The top and bottom are the parallel lines, and that's what this arrowhead indicates, that they're parallel, and they form these angles by making a Z. Now I can also draw a backward Z to find the other two angles. So here's your backward Z. All right, and these two angles, angles 5 and 3, would also be equal, okay, because they are also alternate interior. Likewise, there are alternate exterior angles, which are on the same side of the transversal, but now they're outside the parallel lines. So you can see we have 2 and 8, and then 1 and 7. All right. And there are same side interior and same side exterior. Just remember that same side, okay, both inside or both outside are supplementary. So if they're on the same side, supplementary, okay, except if they're corresponding in the same position. All right, now a good easy way to remember whether they're equal or congruent is, are they the same size? So there's two types of angles here. There's acute angles, which are less than 90, which here you would say is like angle 4, represents an acute angle. An acute angle is always equal to another acute angle if the lines are parallel. That's important, okay? That means the other type of angle has to be an obtuse angle. Remember, they form 180 degrees. That is also equal to any other obtuse angle. I think I spelled obtuse wrong. Obtuse. Obtuse is equal to obtuse. And then if you pair an acute up with an obtuse, they actually add, okay, to 180. So acute are equal, the obtuse angles are equal, and an acute and obtuse make 180. So that's an easy kind of way to remember this. So going into the next set of questions, we want to name two alternate interior angles. Okay, so remember, we're looking for the Z, and we can see there's one right here. So the first angle was this angle, which is ARS. So angle ARS is congruent to, see if we can get the other one. Okay, that's angle RSD. Now you can flip those letters around and call it SRA and DSR, and that's okay as well. But the vertex here, where the R and the S's have to be in the middle, okay? Two pairs of alternate exterior angles. So alternate exterior angles, I'm just going to erase our markings here, okay, are always on the outside the parallel lines and opposite sides of the transversal. So that's ERB, and then switch sides and lines, and that would be this one. So angle ERB. Oh, by the way, that's only one set. The other one comes from the other direction. So that's angle BRS, and that's congruent to angle CSF. Okay, what I'll do is I'll name one and I'll have you do the other one. Okay, I'll pause it and do it so we can save some time here. So angle ERB, and we said angle, we could call this CSF. If you said FSC, that's also okay. We need the angle symbol in there to identify that's not a plane, it's an angle. All right, name two pairs of corresponding angles. Remember, corresponding angles are in the same position. So there's really four of those sets of angles here, okay? So if we start in the top left here, we have to do the top left here, okay? Same position. So angle ERA is congruent to angle top left RSC. And I'll have you do the second one on your own in a minute, okay? Vertical angles, there's another four pair of those, okay? So vertical angles, when the two lines cross here, they're the opposite angles. So these two angles are vertical. They form a bow tie, okay? They form a bow tie. So this would be angle ARS and angle ERB. That's one set, okay? Name two pair of same side exterior. So we're going to go, well, let's go same side interior. We're going to stick in the order here, E. So same side interior would be, I have to be inside the parallel line. So that would be this guy right here, okay? So angle BRS, and the other one is going to be RSD, I should say. So plus angle RSD, and that's equal to 180. So we'll write the relationship in there. All right. Likewise, we're going to do same side exterior. So we'll go on the other side this time. So that's angle ERA over here. And exterior, same side, would be CSF. Angle ERA and angle CSF. And remember, I already made an error, okay? Those two angles are not congruent, right? They add to 180. And if ERB is 72, so if this angle is 72, what is the measure of angle CSR? So CSR, we can see, we'll highlight in blue here, this angle, right? And the other angle we're talking about is the one that's down here. Okay, CSR right here. So these aren't really related, but we can think about taking this angle and shifting it down to its corresponding angle. And now we can see that if this angle was 72, that these two angles are equal, because they're corresponding. And now I can see that these two angles actually form a straight line, right? They're supplementary. So I can figure out by doing 180 minus 72 that this is 108 degrees. So the measure, that's what M means, of angle CSR, kind of looks like an E, CSR is equal to 108 degrees. Okay, go back and fill in the other pairs of angles here. I'll go do that too. I'm going to pause it and we'll keep going. All right, here are some possible examples for you guys. So we have angle ERS and angle FSD would be the other two alternate exterior angles. Okay. Yeah, it should be ERB. ERB, not ERS. Let's fix that real quick. So ERB, glad we caught that one there, huh? And then FSD. So these are the two angles we're talking about there. Okay. The corresponding angles, you could have chosen a whole bunch here. So I chose ERB and RSD. We could have also chosen our BRS and DSF, and we could have chosen ARS and CSF. So those are the options for that one. The vertical angles, I chose to do CSF and then RSD. All right. You could have also chosen CSR and FSD, or you could have chosen ERA and BRS. So those are your options there you could have picked. Remember the same side exterior angles, we should have done ERB and FSD, two different arcs because they're not equal, add to 180. And then the same side interior would be ARS and RSC there, or CSR, your choice. And those add to 180. All right, those are your angle pairs. And then we're gonna get into some questions involving that. So this is it, guys. So here we can take a look at number 2. We want to know if angle is 30 degrees, which is given. What's the measure of angle Y? And so basically we want to find an angle pair near angle Y that we know the measure of. Now keep in mind, remember we talked about before, obtuse is equal to obtuse, acute is equal to acute, and if I put two different acute and obtuse together, they're going to add to 180. So I can tell that this is acute and this is obtuse, so that's one way to do it. The other option is to say, okay, if this angle is 30 degrees, what other angle near Y is equal to that, right? And I might say, well, this angle is corresponding, so that's 30, right? Or I might say, right about a 3, that's what I might say. Or I might say, well, this angle over here is alternate exterior. So now I can just pair these angles up to make 180. That's another option, okay? But either way, we just want to do 180 minus 30 and end up with 50 degrees, 150 degrees. And we got letter D here, okay? Number 3, what is the measure of angle X? So remember the bow tie angles, right? These are vertical angles, so those are equal, just to review. But these angles next to each other are supplementary. So we would just want to do 180 minus 47. And that ends up with 133, which is choice B here. All right. What is the measure of X? So we can see if this angle is 90 degrees, the angle next door to it also has to be 90 degrees. So I can just do 90 and then take away 67, which should give me 23 degrees. And that's the measure of A. All right, a little bit tougher here. So now I have these two angles, which are vertical angles, and they're equal. So I can set up my equation, 3x plus 11 equal to 125, and then just solve for x. So move that 11 over first. 3x is equal to 114, and then I divide by 3. And x goes into 11 3 times, and how about 38 for our answer. Now be careful that it doesn't say what's the measure of this angle, right? It does say find x, so that's how I know it's going to be 38. I don't have to plug in there. All right. So put B in the line. Number 6, we want to find the measure of angle BHG. So remember, that is BHG, this angle right here. Okay, so I can see these two angles. One of them's acute, one's obtuse. They're same side interior, so they add to 180. So that's my equation, x plus 2x minus 30 is equal to 180. So I'm going to move the 30 over and combine like terms here, okay? So x plus 2x is 3x. This gives me 210, and then I should end up with 70 all the way around, which is choice C. But, timeout, we fell for it. Just told you guys. Make sure you plug in, right? What are we looking for? We're finding for BHG. So if I plug in 2 times 70 minus 30, right, is 140 minus 30, which is actually 110. So we should have chosen D. All right. 7, which is true. So go through and just eliminate answers as you're going through. So FEG, here's FEG, and CBE, those two angles, Are they alternate angles? So are they on opposite sides of the line and like alternate interior? They're not. So I'm going to say that one's a no. Confusing. So we're going to leave that one alone for now. Let's see if there's a better answer. FEG. Hey, that's that one again. And CBE. That's the same thing. Awesome. So we're going to skip that one as well. It could be either of those two. In this case, if this was an option, if this happened on the exam and it was choice A, they would also accept choice B. They would come back with a fix here. But C, CBE, which is this angle, and DEB, which is this angle, are same side interior. That is true. So that is the best answer. Okay. And our FEG, so we'll go black here, FEG, that's this angle, and DEB, there's DEB, those angles are vertical, but it says same side interior, so that's definitely not. So this is our best answer. Those ones are not alternate interior or exterior, that's why we're going to choose them. So C is our most appropriate answer that we definitely know is true. Okay, for number 8, same thing. So see if you can, what's the relationship here, guys? They are vertical, so they're equal. So we just set 5x minus 19 equal to 2x plus 11, and then I solve. So subtract the 2x to keep the x positive, which gives me 3x. I'm also going to add the 19 over to get 30, okay? And then divide by 3 and get x is equal to 10. Now don't choose 10 because it says what's CEA. Now CEA is actually next door here. So I got to find one of these angles and then take away from 180. So we'll plug into the easier one here. We'll do the 2x plus 11. So 2 times 10 plus 11 would be 20 plus 11, which is 31. And so 180 minus that should be like 149, 150 and an extra one. So there's choice B. And the last one, the larger of two supplementary angles. So remember, supplementary, once again, means they add to 180, has a measure of 20 more than the smaller angle. This is a word problem, so we need to get in the door, we need a key. So we're going to say it's 20 more than smaller. So I need to know the smaller first. So x is equal to the smaller angle, which means that the other one is 20 more. So that's x plus 20. That's the larger angle. And now I can create my equation and solve. So x plus 20, the two angles are supplementary. So add to 180. So I'm going to do two things. 1, subtract the 20, and 2, combine like terms. So 2x is equal to 160, which means x is equal to 80, and that is the smaller angle. So we're good. So the smaller angle is 80. And it should make sense because if we add 20 to that, we get 100, and that gives me is 80 degrees. Okay, adds to 180 together. Number 10, transversals cutting through the parallel lines. That's important. So to mark that off, we can put arrowheads on there to indicate that they're parallel. So RAN is 3x plus 24. RBQ is 7x minus 16. These two angles are the same size. They're also, vocab word, corresponding in the same position. Top right corner in both intersections, so they're equal. So we can solve for x that way. Now be careful, we have to find that angle when we're done. Okay. So anytime you have these questions where they have variables in here, you got to think, I need to make an equation. So what's the relationship? And then we can solve. So we're going to move the 3x over first. Remember, we want to keep that x positive. Okay, so this is 4x. And I'm going to move the 16 next. So add that over. And this is going to be 40. We'll divide out and get 10 equals x. And then MAR is next door to RAN. So we'll plug in here. So 3 times 10 plus 24. That's really 30 plus 24, so that's 54 degrees. So 180 minus 54. Let's see, it's 130, so that's 126 degrees. And there's our answer. So the measure M, right, of angle MAR is equal to 126 degrees. If you don't put the little degree mark on here, you're not going to get it wrong. I just want to make sure we know that we're talking about degree measure here. Okay. Ooh, we got a little explanation time here. So the right angle is intersected by DE. What is the measure of angle DCB and ACE? So, one, we know that it's a right angle. Okay, so we're just going to do our work real quick. 90 minus 37 is equal to, so that's going to be 60, so 53. And then the other one's going to add to 180 because it forms a straight line. So 180 minus 37 would be 150, so 143. All right, and then we're going to put our explanation down. So remember, we want to use those key vocab words here, right? So we're going to talk about the fact that angle DCB is how many degrees? What did we get? 53 degrees, right? And then why? Why is it 50 degrees? Okay, since angle DCB, good spell there, all right, is vocab word complementary to angle DCA, right? And then why? They form a right angle. Okay, you can use that angle symbol for yourself. Fortunately, I'm stuck with the less than symbol here, but that's okay. And then that's the end of our thought here. So we'll put a dot down period for ourselves. And then in the second line, right, we're going to go ahead and say some cool stuff, right? What's the other one? Angle ACE is equal to, we got 143 degrees, okay? And then y is 143 degrees, so same thing. Since angle ACE and angle ACD form a straight line and are supplementary. And that's it. There's our explanation. Okay, that's it for today, guys. Hopefully you got a lot out of the parallel lines and transversal. Once again, just something I want to keep in mind as you're moving forward so you know those vocab words. Prep you guys for next year for some geometry time. That's it for today. Have a great day, guys. Remember to get that Nearpod done. We'll see you tomorrow.